Welcome to Unit 1, Lesson 6. Back to solving quadratics, guys. We're back at it. Oh boy. Hopefully by the end of this lesson, you will be able to solve quadratic equations with real coefficients that have complex solutions. What does that mean? That means we're using the quadratic formula, gentlemen. It's not going away. I put that little diagram there for you. That's a circuit diagram of electrical currents, because the only real-life application of complex solutions or complex numbers where you're going to see it much at all is in electricity, in particular dealing with impedance and alternating current. If you're kind of curious about that, or if you know anything about sound and impedance, there's a similarity there. So enjoy, look it up, see what you can find if you have time or you care. But that's where you're really going to see a lot of complex number usage. All right? So let's get busy. Here's the think about it question, guys. Consider the function f of x equals x squared plus 3x plus 3. We basically solve it for you already. It's almost completely solved. I want you to finish solving this problem in your notes. I want to see it completely solved in your notes. Then I want you to think about these two questions, and then I want you to answer them. Okay? Answer number 2 and number 3 in your notes. Don't just think about it, but think about it and come up with some sort of answer. Okay? Think about it and answer it. I want to see this written down in your notes. The answers as well. Okay? You should have all the tools to answer this question. Not just think about it, but actually answer it. I feel like a broken record. But please answer it. All right. Let's get back to it and let's do some problems together before you get into your own practice problems to make sure you've got this quadratic formula thing down and solving quadratic equations. All right? So what was the quadratic formula again? I'm going to write it over here in the corner for you. It was x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to commit that formula to memory, guys, all right? You absolutely need to commit that to memory. Now, hopefully you know how to use it. We've gone over that before, and it's the same exact thing as before. We identify what a, b, and c are. A is 1, b is negative 3, and c is 10, and I plug those things into my formula. I'm going to write them down for you so that you are aware of what they are. So we know that a is 1. We know that b is negative 3, and that c is 10. So knowing that, I can plug those into the quadratic formula. So it's a negative 3 plus or minus square root of b squared, so that's a negative 3 squared, minus 4 times 1 times 10, all over 2 times 1. Two negatives always make a positive, so that's 3 plus or minus the square root of 9 minus 40 all over 2, which is equal to 3 plus or minus the square root of negative 31 all over 2. Now, since we have that negative under the radical, we're going to pull the negative out by turning it into an I. So that's 3 plus or minus I root 31 all over 2. Remember, guys, that I is equal to the square root of negative 1. So the square root is still there. We just use I to represent it. Okay? And so my solution is x equals this set of answers. Okay? This is actually two answers, right? It's 3 plus I root 31 over 2, and it's 3 minus I root 31 over 2. All right? I like, when I have square roots, I like to write the I in front of the square root so that I don't get confused and put it underneath the radical, because it really isn't under the radical, okay? Let's try this next one together real quick, and then it'll be all you. All right? So, why don't we pause the video and you can take a stab at it. Take a try at it yourself. All right? And then after you try it, then we can check your work together against my work, okay? So you can pause and try it now. All right, so we have A equals -1, B equals 5, and C equals -6. Okay, I'm hoping you could all recognize that now without having to write A, B, and C every time. So we have a -b, so it's going to be a -5 plus or minus the square root of 5 squared minus 4 times a -1 times a -6 all over 2 times a -1. So that equals a -5 plus or minus the square root of 25 minus 24 right, all over a -2. So as we solve this, we get a -5 plus or minus square root 1 all over -2, which is a -5 plus or minus 1 all over -2, which is going to give me 2 setups here. It's going to be a -5 minus 1 over -2, which equals, that's going to be 3. And then the other one we're going to get is -5 plus 1 over -2, and that is going to equal -4 divided by -2 is 2. So our solutions are x equals 2 and 3. All right. There you go. There are 2 different problems with 2 different solutions, both of them using the quadratic formula, and that's what we want to do in the next set of problems, guys. So I'd like you to try these. All right, numbers 9 through 18 you should have absolutely no problem doing. Remember, you need to put the equations in the proper form, right? They have to be in standard form. And standard form, for those of you that don't remember, was this: ax squared plus bx plus c, and it's equal to 0. That's the form you need it to be in, right? You need to set it equal to 0 to solve, so everything has to be on the same side of the equation. My hint to you guys on number 19 and 20, all right, is to think of x squared as, or x to the 4th as x squared. Think of x to the 4th as x squared, and then use the quadratic formula on those. So what you get is, what you end up solving for instead of x is x squared equals whatever you get from the quadratic formula, okay? Hopefully that's enough for you to get numbers 20 and 19. I need to see you attempt them, right, and try them. And then there's also 21 and 22. You have fractions. Do we like fractions? The answer is no, we don't. So you should know what to do with them, okay? Thank you guys. Have a good night, and I will see you later.